So we'll get started. Thank you everybody for being here. I'm excited to talk about this topic because I feel really passionate about multi-tenancy. And I think multi-tenancy can change the world, and we see examples of it changing the world around us. Uh, so I want to talk a little bit about some of the counterintuitive things about multi-tenancy, make a case for multi-tenancy, and dive into what some of the building blocks are that really power multi-tenant architectures. But just I have to preface this with you can listen to me and burn your hour, but if you want the real experts, two people that I really admire in this particular domain, and we're going to dive into some of their work in a bit. Andy Warfield he recently wrote a paper on S3, and it's very casually titled. It's like building a pretty large storage system. It's S3, it's pretty large. But he gave the keynote at the FAST conference, I think last year, and it is an incredible paper. You have to read it. And then there's Mark Brooker. I've been following Mark for a very long time, and I don't think I'll ever get smart, but I've learned a lot. Every time I read something from Mark, I always feel smarter. And so often when I'm in a technical discussion, I find myself saying, Mark Brooker wrote a blog on that. Let me go dig that up. So if you haven't read some of his blogs, I highly encourage you to do so, and we'll dive into one of them here. So the why of multi-tenancy, I wanted to just talk a little bit about the current competitive landscape. And I don't mean current competitive landscape in the cloud ecosystem by any means. What I'm talking about is the internet is the new mall for everybody, and everybody is building applications. And it is literally a fight for obtaining, sustaining, and retaining eyeballs. Everybody out there is building new experiences, and everybody out there is trying to iterate really quickly to build new experiences. And the pace of iteration in the world has changed meaningfully because the standards have changed in terms of, how fast everybody is innovating, and people are building out whole new types of concepts, content, and just fighting for engagement from your eyes to on your mobile device or your web browser to their applications. And what that means is, in this world, people who are fighting for the eyeballs have to be able to iterate rapidly. And once they land on a successful experience, they have to be sustainable. And what sustainable means is they need to be able to sustain the rapid iteration. The cost needs to be sustainable, so it can't be something that works and then pretty much falls apart as soon as you can't afford it anymore as soon as you put it in practice. And the architectural simplicity also has to sustain. They can't make the architecture more complicated just because more people showed up. And if you get this right, you can continue to iterate really quickly. And this is the fundamental thing that multi-tenanted systems enable. And this is also the fundamental hypothesis of why we built Momento, but we're not the first ones to have this insight. All the cloud providers are basically working off of this insight, is to just take the undifferentiated heavy lifting off the customer's face and off the developers, and just let them focus on the actual building of their experiences. So we talked about sustainability at scale. You got to have performance, scale, cost, architectural complexity, and feature velocity that you got to retain. But I submitted earlier that the key to a lot of this is multi-tenancy. And I just want to call out, multi-tenancy is not a novel concept. The day that you provision your first EC2 instance or a major storage bucket on S3 in 2005 or 2006, you were already in a multi-tenanted environment. The fact that the data center was shared inside of the AWS cloud was a multi-tenanted environment. But before AWS, if you were in a colo, you were in a multi-tenanted environment. And even if you ran your own data centers, even if you ran your own racks, well, your computers were manufactured in a multi-tenanted environment. Dell did not just build a facility for your specific company to manufacture. Intel didn't build chips for your specific, I mean, maybe they did, but like you've got to be really big if that was happening, but they weren't building for you. So, when you keep going down the route of where technology is coming from, multi-tenancy has been around us from the very beginning. And you go, like forget technology. You look at a newspaper. A newspaper is a multi-tenanted environment where a bunch of authors, journalists, can aggregate their stories, and they don't each need to have a delivery mechanism to get that story over to your house. It just shows up at your doorstep, and you're reading stories from 100 different authors when you open up New York Times, and that newspaper is multi-tenant. Imagine how bad it would be if every single author had to go figure out how to print, how to deliver, how to make the trains run on time. And, and it's really everywhere. Your car is multi-tenanted. So I'll give you a quick example of multi-tenancy at play. Every year, when I worked at Amazon at reInvent, there is a massive exodus of people leaving Seattle to go to Las Vegas because there's all these Amazonians that are getting on a plane and going to Las Vegas to attend reInvent. And that is a fundamental example of multi-tenancy where Amazon doesn't have, Amazon has airplanes, but it deploys it on other things. The airlines are dealing with all the capacity planning and the management. The Amazonians end up buying tickets on their travel system, and they pay a price, and they just show up. They don't have to, nobody at Amazon has to worry about what model of seats are in the Alaska Airlines flight that's flying from Seattle to Vegas, or the fact that there's Amazonians in cities that are not Seattle, or the fact that there's other people showing up. And sure, it would be cheaper if Amazon owned planes that transported their employees from Seattle to Vegas. Unit price would be cheaper just for that moment in time, but boy, would those planes sit idle for the remainder of the year. They'll all be 100% idle, but utilization would be pretty damn low. And you can find predictable areas, and you can increase utilization there. But multi-tenancy, like once you start looking for it, you'll find multi-tenancy every single place. And I will just end it with like one other thing. Like, it is so everywhere, to the point where when you see the Amazon Prime delivery truck, maybe not this one, but the ones that's showing up in your neighborhood, like just go back in time today, where like when you needed a carton of milk and you had to run to the grocery store and drive all the way back just to carry your milk carton. And now you can just DoorDash it. And guess what? The DoorDasher or the Dasher isn't really getting your milk and coming to your house. What they're doing is they're picking up a bunch of things for a bunch of people, or at least, 2 people, and then they're just dropping it on the way. That is the type of efficiency that multi-tenancy delivers. In fact, with multi-tenancy, like, applying this to the DoorDash experience, like, I kid you not, I ordered Chipotle one day from my house. The Chipotle is a 12-minute drive away. If I got in my car, I went to Chipotle, and I came back, it would be 24 minutes of just driving time, plus the time to go in, order, get the thing made, and come back. And I timed it this one time. Like, I have my timers. I've never been able to go from my house to Chipotle and come back in under 30 minutes. DoorDash's fastest time is 25 minutes to my house from a Chipotle order. It's multi-tenancy. The driver is already there. They just bring it back to me, right? There is a driver somewhere in the vicinity of Chipotle, and when you get lucky, you can get somebody to bring it instead of you having to do that round trip. That's the efficiency of multi-tenancy. So let's go back to the infra side, multi-tenancy in the infrastructure side. And we're going to cover a bunch of concepts that allow you to reason about what it takes to build a multi-tenanted architecture. And a really, really critical concept in a multi-tenanted environment is peak to average ratio. When you fulfill a multi-tenanted system, when you build a multi-tenanted system, you have to deal with the peaks. It's not the customer that is dealing with the peaks. You have to deal with the peaks. When you build your single tenanted system, you have to deal with the peak to average yourself. The customer, whereas like in a multi-tenant system, the vendor has to worry about it. The example of this is if you have a sedan at home and you got 2 kids, and 2 spouses, that's 4 people. It fits in a sedan. Grandparents show up, suddenly a sedan can't fit 6 people. So now you need the minivan. So that's where like the peak to average ratio really starts to come into play. And this is where if you're relying on a rental car or hotel rooms, you can actually, deal with the peak to average ratio by delegating the peaks to somebody else. But the peak to average ratio is what drives the costs of any hardcore infrastructure behind the scenes. And this is the core secret behind what makes multi-tenanted systems so powerful. What they do, the reason why multi-tenanted systems unlock availability, performance, and costs is simply because they allow the peaks to average ratios across a lot of customers to get blended together and smooth out. So a really clever way to put this is if I take the peak to average ratio of all the customers and I added them up, if I added all the peaks, that number would be astronomical compared to smoothing out their peaks to average. And if everybody inside of AWS today was hard provisioning their peaks, the world would run out of transistors and the capacity that is required to fulfill that. This is true for your internet at home too. You have a pretty damn high peak to average ratio. Most of the time you're not watching anything and boom, you turn on Netflix. You start downloading at 20 megabits per second if you're watching 4K. Or you start a download. You do this massive bandwidth utilization and then it goes to 0. And most of the time it's 0. When you're asleep, it's 0. But what the ISPs are doing behind the scenes is they're oversubscribing. So when they tell you that you got a gigabit per second, you don't actually have a gigabit per second. You get up to a gigabit per second, and there's a bunch of really sharp capacity management that is happening behind the scenes to ensure that they can deliver on that 1 gigabit per second most of the time. And this starts to come into play in multi-tenanted systems. So one of the most fundamental insights that surprised even myself and a lot of people who have been working in the cloud industry for a very long time is Andy's paper basically pointed out today Amazon has tens of thousands of customers with S3 buckets that are spread across millions of drives. Now think about that. Tens of thousands of customers. That's not Fortune 500. That's tens of thousands of customers. So even a tiny company like Momento, as an example, has the ability to deploy 1 million drives for our buckets. It's actually quite simple. If you have 1 million objects in S3, there's enough entropy that you're probably on 1 million drives. And 1 million objects in S3 is not a lot. Now think about that for a second. This is why when you provision an S3 bucket, well, actually, you don't provision it, you just create it, right? You don't go to S3 and say, I would like 50 gigabytes in my S3 bucket, please. You just go and say, make me a bucket, have some data, go away, you come back, is the data still there? Yep. Do I start downloading the data a lot? Does it work? Yep. Can I just throw a lot more data? Yep. I never had to create S3 capacity units or bucket gigabytes or anything. It just spreads. And what that gives you is that instant ability to absorb spikes, whether it's on the amount of gigabytes, whether it's on the IOPS, or it's on the actual download side of the house. And this is why the millions of drives matter. What they do is they allow S3 to absorb and smooth out the peak to average ratio. One single customer does not dominate a single drive. no matter how big you are, your load just gets spread out across the entire S3 fleet. What that means is your spikes are also spread out across the entire S3 fleet. And just taking a second to pause and think about the environmental aspects of it. Like in the world before S3, people literally bought hard drives for their peak, ran them in their data centers, provided the electricity, the real estate space, all of that was there because everybody was provisioning the S3 capacity or the storage capacity for their peaks. And you start breaking down the anatomy of how these systems are built. And almost all of them fall into, if you zoom out enough, they all look very, very similar. There's a client, there's a routing fleet, and there's a storage fleet and a bunch of async workers that are in the background. So this paper, this particular diagram is from, it's a whiteboarding between a session between Andy Warfield and Seth Markle. I think it's in the paper as well, but this is as simple as the architecture of S3, but pretty much every hardcore multi-tenanted system that's out there. Let's dive into DynamoDB for a second. Looks very similar. You've got the request router that's handling the authentication. You've got the global admission control, and then you've got a set of storage nodes behind the scenes that are storing the data. And we come to Momento. So now we'll dive into how some of this applies if you're building the system from scratch, and we'll open up the kimono and basically show you how Momento is built. But you can see it looks very, very similar. And by the way, this pattern is not specific to Amazon. You go to Facebook and you look at the way Crowder is deployed, same thing. You look at the way Cosmos is deployed and Microsoft, same thing. It's this whole notion of a load balancer, a routing fleet, some storage nodes, and an intelligent control plane. That is what powers, essentially almost all multi-tenanted infra services. And there's some separation of concerns in the components that we build in Momento. And the three components that we'll dive into are routing, control plane, and storage. So routing. You're supposed to be, this is a stateless fleet, and it's very, very important to internalize that it is a stateless fleet. Because it's stateless, you can horizontally scale the hell out of this fleet. And what it's supposed to do is to be able to absorb a different type of load than, let's say, a storage node has to absorb. But one of those differentiations is millions of connections. There's a reason why the world needs RDS proxy to be able to open millions of connections to RDS, but they don't need a DynamoDB proxy. They just use Dynamo. Dynamo has that request routing fleet. You open 1 million connections from Lambdas to Dynamo, Dynamo will just yawn. Sure, that's cute. Try doing that to your RDS node, you will probably cause an outage. Try doing that to your Redis node, much worse outage. With a single-threaded handling of network connections. But it also does something else. Some other things other than absorbing and vertically scaling or horizontally scaling for handling connections. It authenticates. Unauthenticated requests don't end up hitting the storage nodes at all. It protects them and it serves as this shield to only let authenticated requests go through, which is good for scaling as well. The other nicety here with services that have this routing layer, especially in S3 in particular, DynamoDB calls its routing layer a request router. S3 calls it a web server. And, I think S3 has it right. The nicety of the routing fleet being a web server is that you can basically, it's a signal to the world that if you want to connect your mobile application directly to S3 to download the data, it is totally fine. You don't want to do that with Dynamo. It's not built for that. It's mostly built for internal services, inside of AWS talking to it. Then the router actually has to do some routing, right? Like once you have authenticated, once you have terminated the connection, terminated the TLS, you have to actually know where to send the data. But the reason why the routing is important is that you have to be able to absorb topology changes without the customer noticing that the topology has changed at all. And topology changes happen all the time. If you're deploying, if there's a node failure, if you're scaling up or down. And this is why Elasticache, RDS, Aurora, they all have maintenance windows because there isn't that routing layer that can absorb and make things seamless. This is why you don't have to pick your maintenance window on Dynamo or S3. It's also why you don't have to pick the version for Dynamo or S3 because the routing layer makes it so easy for the team to just keep deploying behind the scenes and you will never know it. And that is the fundamental promise and feature of a routing layer. It simply absorbs any topology changes. The control plane, different people call it different things. Like in the S3 diagram, it's asynchronous tasks. In Dynamo, it's called auto admin. Inside of Momento, we call it the intelligent control plane or cache admin, But basically, what this component is doing is it is responsible for placement. That means when a cache is created for us, it decides, well, where to put the cache. It also means that, sorry, 1 second, let me just, right. So it is responsible for placement. It is responsible for deciding, when a cache comes in, which, where does it actually go? In the Dynamo land, if a storage comes in, where does it actually go? If a database table gets created, where do you put it? It is also responsible for heat management. It is deciding that, hey, does my fleet have enough capacity and is it distributed appropriately? Do I have some nodes that are really, really idle and some nodes that are really, really hot? Can I move those things, move the databases or the caches around to reduce my peak to average ratio between the nodes themselves? Because if I reduce the peak to average ratio across my fleet, I end up increasing my utilization of the fleet. And then it is the thing that micromanages deployment. It's the brain of the system. It is, and we'll get into how deployments are actually done in these scenarios as well. And then the storage node is very simple. You keep the data, you do replication, you're able to, bootstrap a new node, you emit the metrics, and you just perform. Storage nodes are typically very, very dumb on purpose. They should not be fancy at all. They should just take the data when you tell them to, give it back to you when you ask for it. They should be able to absorb the data from a different node, in case of a deployment, and they should be able to, warm up a new node when it's their time to kind of move on and be undeployed. So if you put this in practice for deployments in particular, the control plane manages it. The routing layer absorbs it so that it's a thick layer of abstraction so the customers don't even notice. And the storage node is the thing that bootstraps, other storage nodes. That's it. But then there is storage node failures, right? Like there's failures that can happen. And sometimes the storage nodes fail. So how does that happen in practice? The control plane observes that a storage node has failed. So you might be, in the Dynamo world, it's called being subpar. And you might want to add more capacity. So you add more replicas and say, okay, cool, we're healthy now. But the control plane is the thing that is going to observe that, hey, this thing needs to have 3 replicas, but it only has 2 because one of the nodes died. As soon as the control plane observes, it needs to tell the routing layer, hey, please don't send any requests to the storage node that just went down. It's going to fail. So what's happened there in this very tight loop is that control plane and routing layer working together have absorbed the fact that there was a failure on the storage side. And the clients may never see or notice that the storage node was down. Now, you can't sustain that forever. So what does it do? It immediately starts to add capacity into the fleet and says, hey, one of the other two replicas, please warm up this new node. And then you update the routing layer again and say, yep, this particular partition now actually has 3 replicas. Feel free to go to any one of them. Again, new capacity got added, customer would never know it. This happens in Dynamo and S3 all the time. You just would never know it. But that's the storage node failure. You can also get the routing nodes to fail. And, this one is a lot easier to deal with because the control plane observes the capacity gap. Because look, like there used to be 5 request routers and now there's 4. And then it says, do I need 5 or is 4 okay? 4 is okay, then it's like, cool. But, maybe I need 6, so I'll just add a couple more, provisions them, bootstraps them, and adds them to the load balancer. In this particular scenario, the load balancer helps out the control plane too, because the load balancer has health checks, and it can say, yep, this node is failing the health checks, so I'm going to stop routing traffic to it. So the failure mitigation actually becomes even quicker because there's multiple parties that are watching and can react to these types of failures. And again, at the end of the day, statelessness rocks. So that when we talk about separation of concerns, we also have to embrace the fact that the routing nodes are stateless. They're like cattle, and the storage nodes are more pets. Like in a Momento storage node, if it goes down, then you are risking cache hit rates, which is not the end of the world, but it's something that we do keep holy. In the Dynamo side, storage nodes go down, you're risking durability. Now, deployments and node failure, if you zoom out enough and you squint, they reduce to the same kind of tractable problem here, which is, you're just replacing a node. In one case, you are doing it intentionally and deliberately, and in the other case, you're reacting. But the really cool thing about multi-tenanted systems is that it forces you to confront the deployment problem. And by being forced to confront the deployment problem, you automatically deal with failed nodes problems. Because, oftentimes they say like backups are easy, restorations are hard. So you can say that, yeah, I got a plan, but you'll never know if your plan works unless you're constantly practicing it. Multi-tenanted systems are constantly deploying. So they're dealing with failures. They're doing fire drills constantly because they, bring up a new node, bring down the old node, move the data. All of that exercise is happening routinely. Oh, sorry, I started with a Spider-Man pointing at Spider-Man, but I just thought I would make an honorable mention to Mo pointing at Mo. Deployments and failures are basically a very, very similar problem. Now, the other thing that you have to deal with in a control plane or in a multi-tenant environment is heat management. When Amazon tells you that this particular set of lights is available if you order within the next 12 hours, what they're doing is they're forecasting the capacity that is available on the delivery trucks, whether, and on the fulfillment center near your house where this item may or may not be available. And based on that, they're giving you some promises. And what they're doing there is they're mitigating the heat. And this is just a form of a throttle, if you will. It's just saying, yep, I can forecast, like this is the capacity I have. But what happens is if like the fulfillment center or your delivery route gets overwhelmed, they can just say it's not going to happen at that time. But what they're doing on the fulfillment side, what Dynamo is doing on the placement side, and what SD is doing on the placement side, what Momento does on the placement side is very similar. You observe the capacity of the fleet across the various dimensions, right? Whether it's memory, whether it's network, whether it's the CPU, you're just observing the capacity. And of the whole fleet, you observe the capacity of every cache or every table and make sure that every table and cache have enough capacity to be on the gigabytes, on the network, on the CPU. And you're doing a few things. One, you are, for when new caches come in, you clearly just put the partitions of the cache on the coldest nodes. And by doing so, you're just trying to move the fleet towards a more consistent heat profile. And that works really well for new caches that are coming in because you're like, yep, the caches on this node seem to be idle. What it doesn't work for is spikes. If you did just this, you're not going to be able to deal with spikes. And spikes happen, right? They happen in retail, but they also happen in the infrastructure world. And by the way, you're not going to necessarily get the same delivery time during Prime Day as you do in the regular season. But there's this notion that multi-tenant systems use of warm pooling. What that means is that they may actually have some capacity that is deliberately sitting idle and is not deployed so that it can just be used in practice as soon as a customer needs a spike or has a spike. And here's where it really matters. If you have an Elasticache cluster and you hit a spike, auto scaling has to observe that. It has to make an EC2 call. EC2 nodes have to show up. You have to tell Redis Sentinel that your topology has changed. You have to absorb the topology change across all of the clients of the cache. And by the time it's all said and done, the observation, the provisioning of the new nodes, the heating of the new nodes, the update of the topology across the clients, it could be many, many minutes. Whereas in a warm cooled environment, what you can do is say, yep, I already got the EC2 instance. As soon as I detect that something is, more capacity is needed, I can just add more partitions to absorb that capacity without waiting for new instances to show up. And if you have a tightly controlled routing fleet, well, you just have to update the routing fleet instead of waiting for every single client to become aware of this. The other key tool in building a multi-tenant system is throttling. And the best throttles are the ones where you don't even kind of observe it. And they exist in real world too. I'll give you an example. Try going into McDonald's where they have like the ketchup packets in the middle and just grab all the ketchup packets and walk out. Chances are that somebody will say something. But if they don't, just go back and try it again. And what you'll observe is, well, the ketchup box is empty. Your token bucket is empty. You can't actually grab more. And if they are really on top of their game and they're refilling it as quickly as possible, somebody's going to observe and say, hey, please stop taking our ketchup packets. And that is a form of a throttle. You observe this in EC2. If you try to provision, if you make a brand new account, try provisioning your 21st instance, it'll just say, no, please request a limit increase. And what they're doing is it comes down to reducing the peak to average ratio and mitigating noisy neighbors. Like a new workflow shows up and just starts to take capacity away. That creates dynamicism that is harder to control. And so, but once customers ask for limit increases, that helps you forecast. And that helps you get time to kind of absorb some of these capacity spikes. And, once the customers have requested a limit increase, what they're doing is they're giving you a hint into the system that says, hey, I might go above this particular amount. You see this with credit cards too, right? Like try buying a whole lot of stuff on the same day on your credit card. Even if your credit limit isn't raised, at some point, suddenly something at the credit card companies are saying, whoa, that's way too many transactions. This is unusual. Let me put a pause on it. Let me call you, make sure it's okay, and then I'll let you go through. Some of the tools that we use in Momento to absorb spikes. So number one, spread the load. It's the whole S3 thing, right? Like spread the load of every customer across as many nodes as you possibly can so that no single customer can overwhelm a single node. Our routing fleet will cache the hotkeys automatically for very low periods of time. Like you'd be surprised at how much like a very low TTL cache, like 10 milliseconds, how much of a difference it can make on the storage nodes. Control plane will add capacity, and the control plane updates the topology. And it's like Futurama, like when there's a Futurama episode where Bender meets God, and God says to Bender, when you do something right, it's as if you have done nothing at all. This is what the Dynamo and the S3 teams are doing all the time. They're adding capacity, they're doing checksums. Billions of checksums per second are happening inside of S3 to keep your data durable. Billions of checksums per second across S3 to keep your data safe. And they're doing something right, and it's as if they did nothing at all, because as a customer, you would never know it. So that is the burden that you hold on yourself as a provider of a multi-tenanted service. And let's for the final chapter of this talk, I want to get controversial. I have a blog on this as well. It's called The Dark Art of Multi-Tenancy, where I cover some of the concepts that we covered today. But I want to say some of the controversy out loud here. High utilization is overrated. You might think that to build a very successful multi-tenanted service, to make it profitable, you need like 60 or 70% utilization. And the reality is that the bar for utilization is quite low, just because of the insights that you're just absorbing the peak, and smoothing the peak to average ratio across customers. I'll give you an example. You go outside and you look at a bus, and the green slots on the bus on the left side, the green slots are the empty seats. If you see a bus that is half empty and you're sitting on it, it might look to you as actually, sorry, the green is like occupied, because I just noticed that there's a driver's seat, and you would hope that it's occupied. Anyways, when you look at the empty bus with 50% seats empty, you might look at it and say, wow, that's pretty low utilization. And this cannot be profitable or efficient. You look outside and you see most cars on the road have one driver and 0 passengers. Those cars are individually running at 20% utilization. And then it hits you when you realize that most cars right now are not actually on the road. Most cars are parked. So you'd be surprised at how much EC2 capacity, whether it's for RDS, Elasticache, whatever, it's just sitting there idle. The bar is 0% utilization. And a multi-tenanted system, even at 10% utilization, especially for those, really spiky systems, 10% utilization is really good. 50 is like magical. And as soon as you realize that, you realize what you can do for the world by making these multi-tenanted systems. And we see this not just for SaaS providers. With the advent of microservices, everybody's building hundreds of microservices, each service having its own clusters that sit idle. That is a lot of waste for the environment. And this is where tools like Lambda, tools like Dynamo really come into play, so that you're not sitting on your own data centers or your own EC2 instances. And multi-tenancy isn't perfect. There are limitations. You can do a lot less than you could. Like, for instance, Dynamo storage nodes can run a lot hotter than the Dynamo team lets them. But it's for a good reason. It's to maintain that consistent experience for everybody. But if you were running Dynamo software yourself and you were the only user, you can probably run it a lot hotter. Similarly, there are capabilities that you will lack just because you just haven't had the chance to build it for the multi-tenanted system. I'll give you a quick example. In the Dynamo team, one of the realizations that we had was every Amazon team and pretty much every serious DynamoDB customer back in 2014 was writing their own backup solution on DynamoDB, right? And they would use, Elastic Data Pipeline, a deprecated service now, to, wake up, scan the whole table and dump the results in S3. That was really inefficient. But the nice thing, the saving grace from multi-tenanted systems is that they force you to have that interface so that all the innovation can kind of happen behind the scenes and customers don't have to migrate to a new system. So eventually the DynamoDB team launched just magical backup system, the point-in-time restore, which is making incremental backups. And all the customers suddenly have the access to just go click a console button, retire their Elastic Data Pipeline, dodgy backup solution, and they all have the world-class solution. So as a platform team, what you realize is the interface that the multi-tenant system gives you allows you to move your entire company behind that thick layer of abstraction without having to migrate every customer to a new platform. The other part of it is that, as counterintuitive as it sounds, multi-tenancy actually improves availability. And it's simply like a lot of it has to do with the ability to absorb spikes. New load comes in and it's just available. You're not waiting for capacity to become available to you or to be provisioned. In the case of Amazon, if they had a bunch of planes, but this year reInvent, more Amazonians were going to go, don't want to sit there and wait for those planes to go and come back. You just want to buy more airline tickets. Multi-tenancy improves availability. And lastly, these systems are not just meant for people who are building external-facing SaaS products. You can build multi-tenanted systems for your own services, for internal-facing services at your own company, and they just improve utilization for you, and the bar for utilization is quite low to actually make it a lot more efficient. 14 years ago, I wrote a paper at NASA about sharing the ground data systems across multiple missions instead of each mission having to provision their own storage and so forth. Right? Especially if you're at a large company, you can use multi-tenanted system. That's a really good start. But there are very frequently opportunities where you can also zoom out and say, hey, everybody in my company is doing X, Y, and Z, and I can share the capacity, I can pool them, and I can offer them behind a tightly controlled interface that I can use to innovate behind later on. And with that, I'll turn it over for any questions or comments that people have. And I just put the original photo from that Alan had put on the organization of this. That's me and Tony 10 years ago when I was working on DynamoDB. Tony's our head of product at Momento, and he was visiting me in Seattle for my birthday, and I got a page running DynamoDB, and I was handling that page, and we took a moment to take this photo. But that is the bar that you take on when you run a multi-tenanted service, because you deal with the outages so that the customers don't have to. Right. With that, I will pause and answer any questions that you all may have.
I have like 12 questions about that photo that was just up, but probably keep it to multi-tenancy.
I've got a question if it's okay to ask.
Yeah, absolutely.
It was regarding probably about 3-4 months ago, there was the database system, the SQLite system Turso, that had the data mangling incident where in a multi-tenanted system, they reset some keys, which basically caused a data leakage from one tenant into another client's data. In terms of the risks for it, particularly at a corporate level where there's huge, in, for example, the EU, we have this GDPR legislation where the consequences of losing terabytes of customer data, be it personal bank details, addresses, national insurance numbers, can result in fines that are a quarter of your yearly turnover.
Yep.
I was just wondering your feelings on the sort of sensitivities of that, and does that cause sort of panic or sweats for you guys when you sort of look at the consequences of keeping data siloed?
Absolutely. I think this is a great question. In the dark part of multi-tenancy blog, I talk about this notion that some of these risks apply even in single-tenanted systems. Right? The example I give is your airplane is rarely going to be out of gas, but like my car at home, single tenanted, my wife and I share it, it's out of gas a lot. And it's because of the fact that when people are running a multi-tenant system like an airline, the level of rigor that is in place explicitly, the level of checklist that your airplane pilot, the ground control system goes through to make sure that common outages are mitigated, common risks are mitigated is insane. When you start paying attention to it, it gets really, really impressive to the level of detail that it dive into. Data leakage happens in single tenanted systems all the time. And I would make this akin to car crashes happen all the time, but when an airplane crashes, the news will cover it, right? Because there's a burst of a lot of lives impacted simultaneously. But they happen way more rarely than the aggregate of car travel. And there are prominent examples of single tenanted data leakages, and not to pick on anybody, like this kind of stuff can happen to anybody. OpenAI had a huge data leakage where they were running their own Redis clusters, single tenanted Redis cluster. And the client, the SDK that they were using was leaving state on the wire. And they accidentally sent, state from a conversation from one customer to conversations of other customers. In this particular case, it's not their single tenanted Redis cluster that had the problem, it was their client. And the thing to realize is whether you think you're multi-tenanted or not, you are multi-tenanted. All multi-tenanted services do is they are very, very explicit about identifying these risks and explicitly doing things like checksumming to put in extra checks to make sure that it is the right data is going to the right customer and so forth. And they put those guardrails in place. So it's unfortunate when data leakages happen. They're very serious, and that is a call to action for even putting more rigor. Last thing I'll say is, you get to put in place best practices by default in multi-tenanted systems. You get to decide that by default, you're going to use TLS. By default, you're going to have authentication. Single-tenant systems are very wild, wild west. You turn on Elasticache by default, like no TLS, no credentials. It's on your VPC. Anybody can access it, right? And that's powerful because it's very nimble. But with multi-tenanted systems, like the governance just goes through the roof because you can impose all of the best standard practices for availability, cost optimizations, and security. So it's a very long-winded answer, but
thanks for that. Thank you.
So I've got one, Alan. So balancing usage against peak and average, love that. I mean, I love that your article, Dark Arts of Multi-Tenancy. How do you look at it from a business standpoint against managing cost against profitability in a way that you're still serving and maintaining customers, right? So that they're getting what they need, but then you're not flipping yourself upside down by running at a price that you can't deliver on.
Very frequently, I run into customers that are running at ridiculously low utilization. I'm talking like below 5% utilization. And I ask them, like, why? Like, why haven't you just turned on auto scaling? And I put myself in their shoes and they're like, well, I'm busy building my product. And honestly, like, it takes a context switch to go through and optimize utilization. It's things that a developer doesn't have time to do. We collect technical debt in our code. We also collect over-provisioned infrastructure debt because what happens when an SDE a software engineer gets paid in the middle of the night because of capacity crunch, they're just going to double the instance size and they're just going to go back to sleep. They might quadruple because they don't want to get paid again, but there's enough layers of indirection that they don't realize the long-term utilization impact that they have just created. So at a high level, the utilization bar across the whole world is ridiculously low. And if you are running enough infrastructure behind a common interface, you are in the business of improving the utilization there. So you take that utilization from 5% to 20%, and boy, are you profitable. Okay? Then there comes the ability to absorb spikes. Everybody has to provision for their peaks because systems can't go up and down fast enough. So that also helps you mitigate, lower utilizations. So, I think this is why I felt so strongly about like utilization is overrated. Like I can tell you from very large production profitable systems that I've run in the past, sub 10% can be quite profitable in a multi-tenanted system, quite profitable, and save money to the customers.
Yeah, I think that's the part that's eye-opening, having not run one myself. 10% is a low number. I would have thought it'd have been much, much higher.
There's a reason why, I'll give you another anecdote. Like for DynamoDB, if you're running less than 14% utilization, you can just turn on demand, right? And you'll save more money just by being on demand. Lots of customers save a ton of money, including internal AWS teams, just by going to on demand. Because it's so hard to get utilization above 14% in many scenarios. Like if you have spiky loads, it's hard. If you have a diurnal load cycle or whatever, sure, that's easy. But lots of load profiles look like this.
Mm-hmm.
Hey, other questions, comments? Somebody gonna go build their own multi-tenanted service after this?
I was just thinking when I had an incident years ago when I was in consultancy, and I had a customer who had a data leak, and the data leak was they had a shopping cart and multiple users were seeing the items of other people in their shopping carts. Well, maybe you can guess what happened, what the cause was. They used CloudFront and they didn't set up their caching key correctly. So it didn't include the user ID. So they had a cache, but they just got results from random other users. Was kind of a big incident. But this is an example of the multi-tenant system. Well, CloudFront is obviously a very multi-tenant system. And if you don't use it right, then you still have the same security issues, even if the infrastructure itself is secure.
Yeah, I completely agree. I think it's the single tenanted distribution still had a leakage because at the end of the day, customers have to take the responsibility of checking in their own hands. The funny thing is that the leakage is made much worse because it happened at the single tenanted level. If the shopping cart data showed up into my fitness app, it would just be garbled up. But the fact that it's coming from another shopping cart, especially if it includes the name of the person, that gets way hairier because my app, like the schema remains the same as well. So one, customers have to maintain the responsibility of making sure that that the data is secure and safe and isolated. And two, it's leakage is much worse sometimes in a single tenant system.
Hey, Khawaja, so you talked about that routing layer. What is the best routing layer for serverless? So there's a couple of options, API gateway, CloudFront, ALB, some of the stuff like that. I doubt you're using any of those at Momento. Do we have a good enough router for serverless today? And if not, what should we use?
Good enough is in the eye of the beholder. API gateway, Lambda, ALBs, they all serve a very good purpose for different types of scenarios. And you have to pay attention because things improve over time. So if you're using REST endpoints and API gateway, you are most likely paying too much. And that's $3.50 per million requests, and people don't realize that. But then Amazon realized, like enough customers complained. So Amazon realized it and started offering HTTP endpoints on API gateway that are not like the REST endpoints, but they cost $1 per million requests. So you have to be paying attention as to which features do you really need and what new innovations there are available to you. And then if you're even more cost sensitive, you can go to ALB and pay, I think it's like 30 cents. This one, I'm not sure if I fully remember, but I think ALB is like 30 cents per million requests. I could be wrong. There's better experts here than me on that. But the nice thing about doing this inside the AWS environment is you can just pick and choose. And if you get large enough, you have to get pretty damn large where $1 per million requests versus 30 cents per million requests is actually hurting the bank. At that point, you can decide if you want to go elsewhere or like build your own routing layer. You are right that we're not using any of those because they don't fit our purpose. We build on top of NLB. So NLB has a lot less features than an ALB does. And we wrote our own routing layer entirely from scratch in Rust. And just like, Wi-Fi has wires behind the scenes, the serverless service of Momento has servers behind the scenes. So we run hardcore EC2 instances with a Rust platform behind NLB. We just do it so that you would never know that there's wires behind it.
Thank you.
All right, I'm going to jump in. Okay, good. I did. David beat me to the silence last time. We were over time, so I am here to stop us, unfortunately. But this was really good. Thank you. Every time I get on a call with you, Khawaja, I feel like Will Ferrell and Elf, where it's like, Khawaja, I know him. It's been I'm usually full of questions at the end of these kind of things, and this is so out of my wheelhouse and so an under the covers look at something that's super fascinating, I know, to everybody in this room, because we all build on top of the things that you're describing. It's a real eye opener for a lot of us. I'm going to speak for everybody and say that. So thank you. This is recorded, so we'll put this up on YouTube, and then I know you troll Discord all the time for follow-up questions on here. So thank you again. And now for the standard next week, we have Jason Wadsworth, who's an AWS community builder, coming to talk to us about, I believe I convinced him to call his talk, how to add paid features to your serverless app. And he is going to be talking specifically about how to add like user tiers into an application. So providing different types of features based on tiering. So it's a very pragmatic approach to serverless SaaS. And he will be rounding us out for SaaS April. So don't miss that one. That one's an hour earlier than it normally is. That one is at 11 a.m. Pacific next Thursday. So I think we have it all wired up into Discord now, so you should be getting notifications when these events start if you have the app open. So, but anyway, thank you everybody for attending. This was a fantastic session. Good to see all of you, and we will see you next time.
Have a great week.
Thank you.
Thank you, guys.
Thank you.